Hi again folks, welcome to another free online maths tutorial from CD Masterworks Limited, and today we're going to be focusing on the addition and double angle formulae from the expressions and functions unit. So the three skills we're going to focus on in this session are the double angle sine formula, the double angle cosine formulae, and then we're going to focus on the addition formulae. So double angle sine formulae. So in the formula sheet at the start of your exam, you have an expansion for sine 2a, and the expansion is 2 sine a cos a. So you don't have to learn this expansion off by heart, just remember that it's in the formula sheet at the start of the exam. So a typical exam question would look like, if a is an acute angle with sine a equals 3 over 4, find the exact value of sine 2a. So the common mistake here is that candidates would double sine a, but of course that would give us 2 sine a and not sine 2a. So how we go about answering this question is, first of all, we get the expansion from the formula sheet, and as we can see from the yellow box, it's 2 sine a cos a, and then we substitute in the values. So it's 2 times sine a, and sine a, as it tells us in the question, is 3 over 4, and we multiply that by cos a, which we don't know. So how we work out cos a when we know sine a is we draw a triangle. So here's a triangle with an acute angle A, and then it's just simple SOHCAHTOA. So sine a is opposite over hypotenuse, so 3 is the opposite and 4 is the hypotenuse, and then we simply use Pythagoras to work out the length of the missing side. In this case it would be the adjacent. So it's 4 squared take away 3 squared, 16 take away 9, so 7, but of course we've got to square root that. So the adjacent would be root 7. So the value of cos a would be adjacent over hypotenuse, so it would be root 7 over 4. So we now multiply out the top and the bottom, so 2 times 3 times root 7 would be 6 root 7 in the top, and 4 times 4 in the bottom, which would be 16. So 6 root 7 over 16 simplifies in addition, so we can divide both of the whole numbers by 2, so that gives us a final answer of 3 root 7 over 8, and that's it. So here's a few questions for you to try. So for each of the following, determine the exact value of sine 2a. And if you're working on these questions at home, pause the video now. Okay, you've unpaused the video, so let's go over these answers. So number 1, you should have ended up with 24 over 25. Number 2, you should have ended up with 120 over 169. So question 3 was 12 over 13. Question 4 was 2 root 11 over 25. Number 5 was 21 over 29. And question 6, we should have ended up with root 99 over 50. So for these questions, we've got to be confident in manipulating fractions, and we've got to be confident with dealing with surds, and we've got to be able to use SOHCAHTOA and Pythagoras. These are all skills that we should be familiar with before we can even think about attempting these questions. So moving on, now we're going to look at the double angle cosine formulae. So again, there's an expansion in the formula sheet for cos 2a, but for cos 2a we've got 3 different expansions. So the first one is cos squared a minus sine squared a, the second one is 2 cos squared a minus 1, and the third one is 1 minus 2 sine squared a. So a typical exam question is, if a is an acute angle with cos a equals 1 over root 5, find the exact value of cos 2a. So like the last outcome, again we go to the expansion page in the formula sheet. So we can actually use any formula here, any one. My own personal favourite is the second one. That seems to be the one for me that's slightly easier to work out. So if I choose the second one, 2 cos squared a minus 1, I'll put in a blank template. So I've got 2 empty brackets squared minus 1, and inside my empty bracket I place the value of cos a, which is 1 over root 5, and then it's just a case of evaluating the answer. And to do that, I'm going to square it, double it, and take away 1. So if I square 1 over root 5, I'll square the top and I'll square the bottom, which will give me 1 over 5. I'm then going to double 1 over 5 to get 2 over 5. And if I take away 1, it's essentially 2/5 take away 5/5, which will give me a final answer of minus 3 over 5. So here's a few for us to try. Remember, you can use any expansion here. It's only my personal favourite, it's the second one. So if we're working on these questions at home, we'll pause the video now. Okay, you unpause the video. Let's go over some answers. So we should have got minus 7 over 9, minus 7 over 25, 9 over 11, minus 31 over 49, minus 1 over 9, and 7 over 25. So the last outcome that we're going to focus on today is the addition formulae. And again, these are in the formula sheet with their own expansions. So this is two formulas rolled into one, sine of A plus B and the sine of A minus B. That's just with the plus and the minus being in the middle here. So the expansion is sine A cos B, and if it's a plus in the original formula, it's a plus in the expansion, that'd be cos A sine B. And the sine of A minus B is the same as that, but with a minus sign in the middle. So there's an expansion for cos of A plus B, so that would be cos A cos B minus sine A sine B, and cos of A minus B would be cos A cos B plus the sine A sine B. So sines get the same sign, and the cos expansion's got a different sign. So our typical question would be, if A and B are acute angles with sine A equals 3/5 and cos B equals 12 over 13, find the exact value of sine of A plus B. So just like the previous outcomes, we go to the formula sheet first of all, and we choose the correct expansion. So sine of A plus B expanded would be sine A cos B plus cos A sine B. After that, we're going to draw two triangles, one for acute angle A and one for acute angle B, and this is going to enable us to work out the values for all of the variables here. So sine A is 3 over 5, so the opposite for triangle A is 3, and the hypotenuse is 5. This would give us a missing side of 4 using Pythagoras. 25 minus 9 is 16, and if we square root the 16 we get 4. So cos B, this time the adjacent's 12 and the hypotenuse is 13, and using Pythagoras we've got 169 minus 144, which is 25, and the square root of 25 is 5. And this will now enable us to substitute in the values. Sine A, as we know, is 3 over 5, and we're going to multiply that by cos B, which we also know, which is 12 over 13. And we're going to add cos A, which from the triangle gives us a value of 4 over 5, adjacent over hypotenuse, and we're going to multiply that by sine B, which is going to be opposite over hypotenuse of the B triangle, which is times by 5 over 13. So now we do the two multiplication fraction calculations. So 3 times 12 is 36, and that's going to be over 5 times 13, which is 65. And then we do the second fraction, 4 times 5 is 20, 5 times 13 is 65. And because we've got the denominators the same, we can simply add the numerators to get 56 over 65. Okay, here's a few for you to try. Choose the correct expansion, draw your triangles and work out the missing sides, and then work out the value for each of the questions here. And if we're working on them at home, pause the video now. Okay, we've unpaused the video. Let's see what these 4 answers are. So number 1 came out as 3 plus root 21 all over 8. Number 2 came out as 11 over 5 root 26. Number 3 came out as root 21 minus 2 root 2 all over 5 root 3. And number 4 is 2 root 15 plus root 5 all over 12. And that concludes our online tutorial for trig formulae. Hope you found this useful, and stay tuned for the next one. Bye bye.